Hi everyone. Today we're going to study a method of proving theorems, and this is direct proof. A theorem is a statement that can be shown to be true. We demonstrate that a theorem is true with a sequence of statements that form an argument called a proof. Statements used in a proof include axioms and postulates, which are the underlying assumptions about mathematical structures, the hypothesis of the theorem to be proved, and previously proved theorems. A lemma is a simple theorem used in the proof of other theorems. A corollary is a proposition that can be established directly from a theorem that has been proved. A conjecture is a statement whose truth value is unknown. Now let us study direct proof. Direct proof or direct method is a method of proving the conditional statement P implies Q, or sometimes we say if P then Q. The direct proof consists of three steps. Step 1, we assume that P or the hypothesis is true. Step 2, we will show that Q or the conclusion is true. Then step 3, we will now conclude that P implies Q. Let us see example 1. Prove directly that if x is greater than 2 and y is greater than 3, then x plus y is greater than 5. First, let us assume that P is true. Our P here is that x is greater than 2 and y is greater than 3. Both of these inequalities must be true. And step 2, we're going to show that Q is true. Our Q here is this inequality x plus y is greater than 5. We must be able to show that this inequality must be true based from step 1 assumptions. So what we're going to do is to add the two inequalities. So it means we have this x plus y, it's now written here, is greater than this number 2 plus the number 3. So here they are. Simplifying the right side, the 2 plus 3 is 5. So we are able to show mathematically that x plus y is greater than 5. So Q is true. Step 3, we are now to conclude that P implies Q. So we have this statement, if x is greater than 2 and y is greater than 3, then x plus y is greater than 5. This is the final answer. Example 2, prove that if n is an even integer, then n squared is even. For our solution, you may wish to write the P and the Q in here. The P is n is an even integer, while the Q, that n squared, is an even integer. Step 1, assume that P is true. We will assume that n is an even integer. If that is so, we may write this n to be equal to 2 times k. This k here is another integer. Now step 2, let us show that Q is true. Our q again is the n square is an even integer. Based from the equation n equals 2k, we're going to square this equation. So we have now this n to be squared equals the 2k to be squared. Simplifying the right side, the 2k with power 2 now becomes 4k squared. Let us factor out a number 2 from the right side. So this one now becomes 2 times the quantity 2k squared. We can replace this 2k squared by any variable. Let's say r. So we have n squared equals 2r. This r equals this 2k squared, and this is also an integer. A while ago, we said that the form of an even integer is n equals 2k. So we are able to show that the n squared is equal to 2 times any integer. Therefore, n squared is even. Step 3, we conclude that P implies Q. So we will write, if n is an even integer, then n squared is even. This is the final answer. Example 3, prove that if n is an odd integer, then n squared is odd. Step 1 is we assume that P is true. It means we will assume that n is an odd integer. If so, we may write that n equals 2k plus 1 for some integer k. This is the general form of an odd integer, which is 2 times an integer k and then plus 1. Now step 2 is we're going to show that q is true. So we're going to show that n squared is odd. Squaring the equation here, it becomes now n squared equals the square of 2k plus 1. If we expand the right side, we will have 4k squared plus 4k plus 1. Look now at the first two terms. There is a common factor which is 2. We can factor out that number 2. So we have 2 times the quantity 2k squared plus 2k. Then we'll just copy this plus 1 down here. This 2k squared plus 2k can be represented by a single variable. Let's say m. So the n squared is now expressed as 2 times m plus 1, where m is equal to that 2k squared plus 2k, and we say that this is also an integer. So we're able to show that the n squared here is an odd integer. So step 3, we will now conclude that P implies Q. So we say that if n is an odd integer, then n squared is odd. This is our final answer. I hope you learned something from this video. See you again next time.